Alright, we are going to start off with the mini quiz. So you don't need to put your phones and stuff away, or you don't have to turn them into the side of the room, but I do need you to clear your desk off. So give me 2 seconds to get attendance in. And then I will pass those out. Jack is late. 2, 3, 2, 2. Okay, so only 6 homework points, and it is all matching. So at the top, I have the unit circle description, and then underneath it, I have the interval notation description. So I have it memorized either way. Just match up with which one it goes to. You need those in hurry because you need to be done with this in like 2 minutes. Wait, 2 minutes. Again, it is matching, so the answer choices are at the top, A through F, and then the questions should put your name on it. Probably should also number it as 39. Double check your answers. you can quietly turn it in, please. And then while you wait for a couple minutes to make sure everyone's had time, the next handout we're going to look at is graphing inverse trig functions, which we did actually talk about in your notes, but you could at least do the graph sine, cosine, and tangent parts while you wait. After you've checked your work, you can come turn it in the basket. Sorry, I thought that was clear. Okay, let's give everybody another minute to work in peace, please. working and put in your last choices and then turn it. This is just straight memorization. I wanted to
4 or 5.
grade 6. Guys, not now. I never should be talking over you. I think that's the second time I've mentioned something like that, so. I wanted to grade these and get them back to you right away, because if you thought you had them all right and you actually have some of them mixed up, that can cause problems in this section, which is why I asked you to memorize these after day 1, even though our quiz on this is not until 4-7 quiz is not until Friday. If you forgot to study, it is only 6 homework points, but you guys need to do something different to remind yourself to look that stuff over. Because this is all stuff you're supposed to know anyway. So let me get in the last couple here, and then we'll move forward. Okay, so last time we started section 4.7 and we spent 3 full class periods on that before we quiz. So last class was 1, today will be 2, this is a B week, so Thursday will be 3, and we will quiz on this on 4.7 on Friday. So we got a lot of practice time still left over. But what we are going to focus on today is the stuff that we did not get to last time because we just ran out of time. So one of those things is graphing. So technically we did do this in the notes, but I do want to go over it again real quick. So we will not ask you to graph inverse cosecant, inverse secant, or inverse cotangent, but we may ask you to graph inverse sine, inverse cosine, or inverse tangent. So if you remember what sine looks like, this can be helpful for inverse sine. So what I just quizzed you on was the range of inverse sine. Now I made that matching, which is probably a little bit too easy. You need to know them a little bit better than that, but I felt like that was a good compromise. But the range of inverse sine is negative pi over 2 to positive pi over 2, and range represents the y values that you can use. So inverse sine, his graph should not be higher than pi over 2, and it should not be lower than negative pi over 2. Likewise, you need to know the domains, but the domains are the easier part. The domain of inverse sine is the same as the range of regular sine. And then that tells you that the x values do not exist less than -1 or bigger than +1. So the entire inverse sine graph is going to fit in this little spot right here. Now, to know exactly what it looks like, we need to steal some points from the regular sine graph. And this is where it helps to know this already. 0, 0. Inverse just means you switch input and output, but you switch 0, 0, you still get 0, 0. So there's 1 point. You could maybe think of this point, which is pi over 2, 1. So the inverse would be 1 pi over 2. Switch input with output. And maybe still this point. Negative 1, negative pi over 2, negative 1 would become negative 1, negative pi over 2. The same way that this is not really a straight line. It looks kind of straight, but we know there's some curvature to it. Do the same thing here. Don't try to make this look like a straight line. Try to show a little bit of curvature to it. But that's what inverse sine looks like. So it helps to know the domain and range, so you know how far left and right to graph, how far up and down to graph. But then you can just take a couple points from sine, switch x and y. So that's all inverse means. We do the same thing with inverse cosine. We're going to steal a few points from our cosine graph. But it certainly helps to know the range of inverse cosine is 0 to pi. That means my graph's not going to exist below 0 or above pi. And it helps to know that the domain of inverse cosine is the same as the range of regular cosine, which is negative 1 to 1. So it should not exist to the left of negative 1 or to the right of positive 1. All of inverse cosine is going to fit in this little spot. Just a little. It's not like this is one cycle and you copy and paste it a lot. This is the entire thing. Think of 1 point over here like 0, 1. Switch the input and the output and replot it. 0, 1 becomes 1, 0. Pi over 2, 0 becomes 0 pi over 2. And maybe pi negative 1 becomes negative 1 pi. You can copy over more points if you want to, but just like this is not really a straight line, there's some curvature. Try to show a little bit of curvature here. So that's the entire inverse cosine graph. Yes?
Is it possible to make it go on forever?
No. This is the entire thing. This is the entire graph. This is the only places he exists. That's what domain and range is defining for us. Okay, and so to me, I feel like you're going to have to memorize the domain and range of all of these anyway. So if you just understand how I'm taking the points and switching x and y, that's really the only thing you need to know to graph inverse functions. So last one we might ask you to do. Some years we do, some years we don't. Some years we ask you to graph all 3 of these. Some years we ask you to graph 1. I'm not in control of this upcoming quiz, so I couldn't tell you if I wanted to. But it helps to think about the domain and range. Range is negative pi over 2 to positive pi over 2. Hopefully you knew that for today's quiz. And what range means in mathematics, the reason why we talk about it so much, is it tells me which y values will occur on this function. It doesn't exist below negative pi over 2, and it doesn't exist above positive pi over 2. And then the domain of inverse tangent comes from the range of regular tangent. So this graph goes on forever left and forever right. So think, again, this is completely optional. You could just memorize what the 3 graphs look like. I just don't think that's a good long-term strategy. But thinking about domain and range, kind of box in where your graph's supposed to be. And then we could say, well, we know what tangent, the tangent graph looks like this. And so I could think of some points like 0, 0, switch x and y and replot it. Maybe pi over 4, 1 becomes 1 pi over 4. Maybe negative pi over 4, negative 1 becomes negative 1, negative pi over 4. I don't know. You can copy whatever points you feel like copying. Some of them might be up here or down here though, and so you wouldn't want to keep those. And then it's going to keep this same general shape. So the way this guy has this general shape to him, still going to be the same general shape. It's just that it's being like turned and flipped.
That's what inverse tangent graph looks like. And it matches up with my domain and range. So, yes,
And it will never hit prior to.
correct. So it only approaches it, and so we designate that with parentheses. So the further right you go, the closer you get to pi over 2. The further left you go, the closer you get to negative pi over 2. But the fact that you never reach those y values is why we have to do parentheses instead of brackets. Okay, other than one optional worksheet that I'm going to give you on Thursday, there's no other times. I don't think there's any in our book assignment or anything where you practice these again. So now would be the time. Is there any questions on how to graph inverse sine, inverse cosine, or inverse tangent? Yes.
Does it matter like which way you do the third? Like, for sine and cosine? Not if you flip it, just if the first arc was going down instead of going up.
The first arc's going down instead of up.
Like just because you say like not to go on a straight line and to add like a little curve to it.
Yes.
So does it matter if the curve is going up?
Oh, no, I'm not. Like, are you saying like whether it kind of like,
Whether it goes down.
whether it like inflects out and then in, or versus in and out?
Yeah.
No, I'm not worried about that. This is plenty fine. I'm not that picky on it. Okay, so if you can see, knowing the domain and range of these are important for these graphs. That certainly helps you know where to even bother graphing. The ranges are the ones I told you were super important last class, and this is why I made up the mini quiz, made the copies, made the assignment grade book, graded all of them for you just to try to push you into learning those earlier. And you'll see before we get to our quiz on Friday, you need to know the domain of these also. Okay, was there any other questions on how to graph these, since this basically doesn't come up again? Yes?
Will they ever have transformations? So tangent -1 plus
I mean,
4?
they if you do like a college trade class, you probably would get into some transformations,
Okay.
but no, we don't go that deep.
Perfect.
We're glad if you know what they look like. Okay, we're going to do a little bit out of order of what the agenda says. So I want to go over the one other new thing today, and then I will take some homework questions from worksheet 2. We will finish questions 3 and 4 on worksheet 1 and 2. We skipped those last time. And then hopefully with about 20-25 minutes, I can let y'all start on the book assignment. You won't get very far, but getting some of it done. Okay, one thing I did not show you last class is how to use inverse trig functions with a calculator. So your calculator has to be in radians. Inverse trig functions are only defined in radians. And these calculator questions vary in difficulty. Some of this works out really nice, and some of it is kind of tricky if you don't know what's going on. So if you look at the middle of your calculator, above sine, cosine, and tangent, you've got inverse sine, inverse cosine, inverse tangent. You should have used those once or twice already this year for finding angles. We just didn't go real in depth into inverse functions. But if your question's an inverse sine, inverse cosine, or inverse tangent question, your calculator has been pre-programmed to make these just work. So if you're in radian mode, you can do inverse sine of 0.5, hit enter, and what it says is your answer. It's about 0.524. Inverse cosine is on there, so inverse cosine of that, hit enter, and you can trust its answer. And same with inverse tangent.
Wait, what does the negative mean when you get the answer? Negative radians.
It just means negative radians.
Oh, so it goes, instead of going this way, it goes this way.
Correct. Sorry, I typed all three of these in, and my calculator was in degree mode the whole time, so. Well, I accidentally closed my program, so. So the first one is inverse sine of 0.5. You got that? The second one was inverse cosine of is it 867?
Yes.
Okay, so there should have been answer to number 2. And the third one, inverse tangent, was of negative 0.26. That's pretty sad that I have those memorized, but okay. So inverse sine, inverse cosine, inverse tangent. Those just work. Type them in your calculator. Your calculator basically has a button set aside for those. These should be your first 3 answers. We're going to round to 3 decimal places. So if they were all this straightforward, we wouldn't need to do this handout. So some of these are going to be a little more complicated. The last one, inverse cosine of 1.5. What? So I'm about to hit enter on my calculator on this. What's wrong with this? Why is my calculator going to fuss at me?
It's not below 1.
Does it have?
Okay, where's 1 coming from?
The diameter of the unit circle. Or the radius of the unit circle.
What is it? What's the thing that's you plug into a function called?
Input?
Domain.
The
Domain. Yeah.
What is the domain of inverse cosine? Okay, so the domain
Oh, it's out of the range of the domain.
is negative 1 to 1. And the reason why this is important, it's not like domain is just something that math teachers decide to ask all the time. Domain is a way to describe the numbers that make sense when plugging in. It doesn't make sense to plug in a number bigger than 1. 1.5 doesn't make sense. Also think about what this is asking. This is saying an angle that has a cosine of 1.5. Well, cosine is adjacent over hypotenuse. And since hypotenuse is always the biggest side, how is your fraction ever bigger than 1? That doesn't make sense, right? So you can type that in your calculator and you can hit enter, but it's going to fuss at you and say there's an error. It tries to give you a hint, the domain, so even it understands what's wrong with that. But in the past, sometimes we've had a question like that on a test, and some students will come up and say, I think my calculator's not working, can you help me? And I can't help you because it's not that your calculator's not working, it's just that you're not thinking about what numbers make sense. So the domain was messed up on that one. So inverse sine, inverse cosine, inverse tangent, assuming it's a number that makes sense, those just work out just fine. Inverse cosecant and inverse secant take just one extra step of work, but it may not be how you would think. Your calculator doesn't have inverse cosecant and inverse secant stored in there. Now there are some calculators that do, so like if you have a TI Inspire calculator, I think it does have these built in. But what you're going to think you should do, and I want you to write this on your paper, but we'll put an X through it, is you're going to think cosecant's the reciprocal of sine, so I will do 1 over inverse sine of that. That's not what you do. Because you have to remember that inverse functions give you an angle. And if I do 1 over an angle, it's the reciprocal angle, which I can't think of a single time in mathematics you need the reciprocal angle. What you need is the reciprocal ratio. And the ratio in an inverse question is what's getting plugged into the functions. So this is how you have to type it in. You have to do inverse sine of 1 over 5.5. For inverse secant, you're going to do inverse cosine of the reciprocal ratio, and you just have to have the peace of mind to know that the ratio is the inside part. So make sure you guys are writing what goes in your calculator. Looking back at this, these final numbers, like, this doesn't mean anything. This is more important to write down than that. But assuming you do the reciprocal ratio and not the reciprocal angle, then they should work out just fine. What's going to happen when I try to type this one in? This is undefined. You can't divide by 0, so that's not possible. If you really wanted to dig deep, like the end of question 2 there, the domain of inverse cosecant is the same as the range of regular cosecant, which was this, and it skips all of the values between -1 and 1. That's why 0 doesn't make sense. Also, you try to plug this in like this, your calculator is probably going to say error division by 0. Can't divide by 0. But assuming that's not happening, you can do the inverse function. Just make sure you do the reciprocal ratio, not the reciprocal angle. As long as you remember that, then these two types are just fine. Okay, take just a second to make sure you end up with these answers as well. Everybody okay with those? Okay, the last one is the trickiest by far. Everybody ready to move on to the last section? Okay, so based on what we did in that last section, you're going to think the way to do these is to do inverse tangent of 1/5, inverse tangent of 1 over that, inverse tangent, reciprocal ratio, inverse tangent, because that's what your calculator has a button for, and as I do these, I'm going to get 5 answers. And 2, 5, 9. Of these 5 answers, some of these are correct and some of these are wrong. Even though it looks like the same type of questions as before, even though it looks like I'm doing the same thing every single time, and my calculator's fine, but there's something about some of these that just don't work. So this is pretty hard to see before you're told, but does anybody have a guess on which ones might be incorrect? Jack?
Their range is too high.
Who is there?
Or
Which ones do you think are wrong?
I think cotangent of, or inverse cotangent of 2.368.
Nope, that one's fine. Did you have a guess, Jonathan?
12.37 and 5, those are wrong.
Those are both right. Yeah.
Just the negative ones.
All the negatives.
To the bottom one.
It's both of these. This one and this one need more work. So I can tell you when to do this, and I can tell you what to do to get your answer, but so that you understand why, so that you remember it, you need to give real close attention here. These are fine. Let me come out to the side real quick. Your calculator is smart, and it has all of this inverse trig stuff programmed in it, even the ranges and the domains. So the way I'm typing these in, the way I'm typing in all of these inverse tangents in my calculator knows the range of inverse tangent is negative pi over 2 to positive pi over 2. So when I type this in and hit enter, I'm asking my calculator, hey, where's there an angle that has this tangent ratio, or this tangent ratio, or this tangent ratio? And it finds an angle in quadrant 1 or 4. These three are perfectly fine because these are in quadrant 1. Well, before I even should have said that, this isn't really the real question. This is just what I'm typing in my calculator. My calculator has no idea that the real question is the inverse cotangent question, and inverse cotangent doesn't exist in quadrants 1 and 4. He exists in quadrants 1 and 2. So if it's inverse cotangent of something positive, quadrant 1, and you type it in your calculator as inverse tangent of something positive, it gives you an answer in quadrant 1, and that's not an issue because both of these exist in quadrant 1. But when you do inverse cotangent of something negative, the way we have to type this in our calculator is giving me an answer in quadrant 4, but the original question is only supposed to have answers in 1 or 2. So like this one, negative 1.24 is almost at 0. So this spot has a tangent of about negative 1/8, or a cotangent of negative 8. So where's another spot on the circle that's going to have that same tangent value and that same cotangent value?
It's going to be directly on the other side of the origin.
Like this?
Yes.
Okay, that certainly puts it in quadrant 2. How do I get from here to here?
Add pi.
Very good. You have to add pi. Add pi takes it from quadrant 4 into quadrant 2. You would be wrong if you did that to these. It's only these two. So you need to highlight those two. Let's update the final answer on those. So when you do inverse cotangent of something positive, and you have to type it in your calculator as inverse tangent of something positive, you don't have to do anything to your answer. In fact, doing something to your answer would make it incorrect, because both of these exist in quadrant 1. But if the question is in, and this is what you might want to write in words, because this is all you really have to know to get the answers right. When you do inverse cotangent of something negative, the way we type it in the calculator, we need to swing it from quadrant 4 into quadrant 2. And the way you do that is you have to add pi to your answer. Calculator's not doing it wrong, it's just working what you gave it. It thought you wanted an answer in quadrant 4, but on these two we wanted an answer in quadrant 2.
That only happens with tangent, cotangent, right?
Only for inverse cotangent of negative numbers should you add pi. Inverse sine, inverse cosine, inverse tangent always work if the numbers make sense. Inverse secant, inverse cosecant always work as long as you do reciprocal ratio. Inverse cotangent works just fine if it's something positive, but if it's inverse cotangent of something negative, you have to add pi to get the answer to the question you meant to get. So again, I would probably summarize that in words, because looking back at, I don't know what you have written on your paper, but if you have all of this messed down, you may not remember what's important. This was the important part of those questions. And we always ask at least one of those on a quiz and one of those on the test, because that's a very good understanding type question. Okay, while all this is fresh on our minds, if we look at worksheet 1 from last class, this is the one that I did with you guys. I showed you how I knew the domain, told you the ranges for a second time, did a few practice unit circle questions, did a few practice sketch a triangle questions. But we had skipped questions 3 and 4 just because of time. And today I will ask you to go back and finish question 3.
What number would this worksheet be in the first 2 functions? 40?
I don't know. The graphing was 40. The calculator was 41. Okay, at the very bottom, these 4 are calculator questions. So if you would go ahead and work those out the way you think they should work out, that's what we just talked about. So if you really understood what you should have there, then you should be able to get all 4 of those correct. But I'll give you a minute to do those, and then I will share my work with you. Make sure those look okay. And then we'll skip over to worksheet 2 and do question 4 on worksheet 2, just to knock out all the calculator stuff. And I guess it's not a requirement, but I do recommend that you guys write what you're putting in the calculator on your worksheet. Again, 4 random numbers don't really mean anything and aren't going to help you review. But take a minute to finish those 4. And when you're finished with those 4, you can glance up at my work, see if you got the same thing. And then please do question 4 on worksheet 2 also. Because when you type this in your calculator this way, it's giving you an answer in quadrant 1 or 4, but this is an inverse answer, and so it wants an answer in quadrant 1. So it's giving you the spot that you want. The only inverse cotangent's a problem, because it wants an answer in quadrant 1 or 2, but the way you type it in your calculator gives you an answer in quadrant 1 or 4. So that's where that one becomes an issue. And only if it's something negative. If it's something positive, you should not do that. good with those 4, or do I need to explain any of those?
Can you explain the first one? You just got, I guess it's just you put the inverse of tangent in
Uh-huh.
15 and then got that.
Yes. Is that not what you got?
No, I understand it. What about the ones like C when you put pi? How did you get that?
Pi, you have to add pi on inverse cotangent of negative questions. Because how you type this in the calculator, your calculator thinks you want an angle in quadrants 1 or 4, but inverse cotangent is really quadrants 1 or 2. So you have to add pi to go from 4 to 2.
Gotcha.
But that's only on inverse cotangent, and it's only if it's inverse cotangent of something negative. You shouldn't be doing that for any of the other questions. Just the only way we can type it in our calculator is the calculator gives us a number different than we expect. Okay, so again, just since we're on this, just go ahead and go over to worksheet 2. And in a minute, I'm going to take a few homework questions from that. But go ahead and take care of question 4 real quick. I'm once again going to freeze my screen. I will also work it out. And give you a quick chance to ask questions if you have some. And I put my answers on the board for you to check as you finish. If you finish earlier, you can go ahead and start the true-false questions on 3, because I am going to ask you to finish those up anyway. But we'll give everybody a minute to finish these 4 calculator questions and make sure that y'all don't have any of these you want to talk about again. Okay, any of these questions from number 4? I wrote out what I put in the calculator to come up with that answer, as I also suggested for you. But your numbers are going to be totally different if your calculator is in degrees. Inverse trig functions, just by definition, only exist in radians, so the calculator has to be in radians. So, any of these you want me to talk about how I got? Again, this is the trickiest one. If it wasn't for this type of question and why you have to add pi, the other three, honestly, we probably wouldn't even take any class time to talk about. But yes.
So we get an answer for sine or cosine, it all has to be less than 1.
Not the answer, the number you're plugging into it needs to be between -1 and 1. Domain represents the numbers that you're plugging in. So this number is between -1 and 1. That's why this one works out fine. This number is outside of -1 to 1, which is why this one doesn't work. What it equals would be the range. But. Okay, so next up, last class we did, so this stuff is important. Again, we might put 1 to 3 questions on graphing inverse sine, inverse cosine, inverse tangent. We will put probably 2 calculator questions, maybe 3 calculator questions on your quiz on Friday. But the bulk of your questions, the bulk of this unit is memorizing domain and range. This will be on Friday's quiz as matching. Hopefully you already know range. I tried to push you in that right direction. And then questions like number 2, where you had to refer to the unit circle, and questions like 2, where you had to sketch a triangle. So I did all of worksheet 1 for you last class, besides the true, false, and the calculator. You still need to go do the true, false. You should have the calculator done now. And then I ask you to try the rest of these. So the chart's still the chart, so I can go over how to come up with these answers if you'd like to, or any parts of question 2. So this is from worksheet 2. These are the ones you practiced at the end of class last time, / homework. Yeah.
Can you do J?
2J. Okay, so a lot of these questions have more than one kind of layer to them. If it does have more than one layer, just worry about the outer layer later. And then just try to work the inside part. Now on this one, the inside part shouldn't be a problem for you because this is not an inverse function. This is nothing new. This is saying if you went to the unit circle at 5 pi over 3, take the sine value there. So take the y value there. So sine of 5 pi over 3 is what you've been doing since week 2 of this class. What's new is now do the inverse sine of this. This inverse, we did not get this in depth until this section. Because this is a unit circle ratio, I would suggest going around the unit circle once and mark everywhere where sine is negative square root of 3 over 2. That can be about a 2-second step if you know the unit circle. I suggest you draw in the range of inverse sine. It is negative pi over 2 to positive pi over 2. Drawing it in every single question helps you memorize it, and we will ask you what they are, just like on today's quiz. But also the visual helps you see where your answer comes from and where your answer doesn't come from. And as much as you want to call this angle 5 pi over 3, 5 pi over 3 cannot be your final answer, because your final answer has to be between these two values. So instead of calling it 5 pi over 3, you need to call it negative pi over 3. Okay, something more specific there? Is that good? Okay, yeah.
How do we know if it's a triangle problem versus a unit circle problem?
If the ratio is something I recognize on the unit circle, like 0, 1, negative 1, 1/2, negative 1/2, square root of 2 over 2, negative square root of 2 over 2, square root of 3 over 2, positive or negative, square root of 3 over 3, square root of 3, just the things that you're used to seeing on the unit circle, then you know it's a unit circle question.
So like negative square root 5 over 6, right? Yeah.
Yeah, that doesn't sound like something from the unit circle, so you need to sketch a triangle. Or the one, I don't know why students think this is any different, but this is not unit circle, so sketch a triangle. X over 1 is not a unit circle ratio, so it's also sketch a triangle. X over 4 is not on the unit circle, so sketch a triangle. To me, this is knowing to sketch a triangle for H and I is exactly the same reason you're doing it for G. But for some reason, when there's X's, sometimes students don't think to sketch a triangle. Okay, what else you got from worksheet 2? Yeah. I? Okay, so like the last question, this one has 2 layers to it. So in the end, I'll worry about cotangent. But for now, I need to think about inverse sine of x over 4. So again, think about what this is asking. This is saying, what's an angle that has a sine ratio of x over 4? X over 4 is not a ratio we memorize on the unit circle, so I know I need to sketch a triangle. But if you just randomly make a triangle in whatever quadrant you feel like, you're only going to get it right if it's a coincidence. So what quadrants does inverse cosine care about?
1 or 2.
2 is over here.
1 and
3 is over here.
1 and 4.
There you go. 1 and 4. So if it's inverse sine of something positive, I'm going to sketch my triangle in quadrant 1 because sine's positive in 1. If it's inverse sine of something negative, I'm going to sketch my triangle in quadrant 4 because sine is negative in 4. But inverse sine only exists in quadrants 1 and 4. So this is positive x over 4, so I need my triangle drawn in quadrant 1. By the way, if you haven't noticed this, and I don't know if I pointed this out to you guys, but of the inverse trig functions, none of them care about quadrant 3. So you should never be sketching a triangle in quadrant 3 in this section. Okay, and then I don't know how this one finishes, but most of these questions finish as SOHCAHTOA, Pythagorean theorem, SOHCAHTOA. So SOHCAHTOA number 1 would be using x and 4. Sine is opposite over hypotenuse. There's SOHCAHTOA number 1. Then Pythagorean theorem to find the other side. You don't always need this, but you usually do. And then SOHCAHTOA to give your answer, because I want to know what's the cotangent of this angle, and cotangent would be adjacent over opposite. So that would be your final answer. Square root of 16 minus x squared all over x. And I can imagine that this answer may feel a little funny because you're not used to having x's in your answer. But if you have an x in the question like this, and part of your triangle sides have x's in it, then you should probably expect there to be x's in your answer too. Okay, was there something more specific on that? No? Okay, is anybody else going to ask about I? Need something more specific? Okay, what else from worksheet 2 did you have trouble with?
What's the difference between say D, where it's sine and then in parentheses square root of 3 over 2, as opposed to just E tan 5/6? That makes sense.
What's the difference between these two?
One of them's in parentheses and the other's not.
Oh, you mean the brackets?
Yes, sir.
Brackets are the same as
Okay.
brackets are the same as parentheses. It's just a different way to write it. Sometimes in math we don't like to say secant parentheses, inverse sine parentheses, in parentheses, in parentheses. It's the same thing. The brackets mean no difference. It's just, I don't know. It's just a little better looking. They're equivalent.
Is there not a difference between Like there's no parentheses between 10 and the number, but there is for D. There's sign and then parentheses, if that makes sense.
Oh, no, this is implied that there's tangent. It's just tangent of this.
Okay.
So whether we put those there or not, it's implied that it's there. Just like when you do a big fraction like this, you guys don't really think about it, but it implies that you do all the numerator stuff first and all the denominator stuff second. So there's implied parentheses. We just don't always write them. Okay. You had something else from her? What else?
G.
G? Okay. So another 2-layer question. So worry about the cotangent later. Negative square root of 5/6 is not a unit circle spot, so that's how I know I need to make a triangle. Inverse sine only exists in quadrants 1 or 4, so I know my triangle has to be in quadrants 1 or 4. I'm going to draw it in quadrant 1 if its inverse sine is something positive, because sine's positive in quadrant 1. I'm going to draw my triangle in quadrant 4 if its inverse sine is something negative, because sine is negative in 4. The reason why it's so important that you guys draw the triangle in the correct quadrant is you need to know which one of these numbers is negative. When we talk about fractions, you can do negative 1/2 like this, or like this, or even like this. You can't assume that the negative goes with the 1 or with the 2 or with either one. You should not be assuming that at all. When we make our triangle, because this is in quadrant 4, because it's negative, when I do opposite over hypotenuse, because that's what sine is, I can see that hypotenuse is always positive, so 6 should be positive, and I can see that this guy's going down, so it makes sense for him to be the negative one. But you shouldn't just be flipping a coin and making an assumption with which one of these two values the negative goes with. Yeah.
And isn't hypotenuse always going to be positive?
Yes. The hypotenuse is always positive. It doesn't care about direction. Okay, so again, I recognize that I had to sketch a triangle. I had to put some thought into what it should look like, but then every one of these questions finishes in the same way. SOHCAHTOA once, which I just did. Pythagorean theorem to find the third side. And then finally, SOHCAHTOA one more time. At the end of the day, I wanted to know what's the cotangent of that angle, and cotangent would ask you to put adjacent over opposite. And if you want to leave your answer like that, that's fine. I mentioned last class that we won't take off points for not rationalizing in this section. If you really want to rationalize in this section, this would be, I don't know, 155, I believe. So either one of those is fine. So I know you guys can do the Pythagorean theorem. I know you can do SOHCAHTOA twice. I know that you can recognize that you've got to make a triangle, but you just have to practice that question type a handful of times before you feel confident at it. Okay, anybody else have one from the homework worksheet 2 before I give others another chance? Okay, anybody that had a question have another one? Okay, then what I need y'all to do to finish up here, we've got we've got 25 minutes. So you should finish up worksheet 1 and 2. So if you haven't done the true false question 3, you should do those. I know I told you you didn't have to do them last class because we didn't have time to get to them last class, but I do want them finished before you turn them in. So finish up worksheet 1 and 2, the true false included. And then if you would get out a blank piece of paper and start that book assignment, you do not have to finish it. You don't have to get close to finishing it. The book assignment is the main thing we'll do on Thursday. But the more of it you get done today, even if it's just a few questions, will make Thursday that much easier because you'll have that much less to do. And I think a lot of those book questions can be, especially the first one, should be very quick once you know what you're doing. If you know the unit circle and you know those ranges, a lot of those questions you can just go straight to the answer. Okay, and of course I'd be happy to help. So if you do come across something today while you're here, go ahead and ask. Raise your hand, call me over, or bring it up here to me. But again, just to be clear, you do not have to have the book assignment finished. You guys don't have to go home and do a bunch of homework. I would say it would be beneficial for you to do just a couple of the book assignment questions outside of class, only in the sense that it forces your brain to think about it an extra time. But I'm not expecting you to turn in a finished book assignment on Thursday. Oh, you guys may not appreciate it as much as me, but this is actually one of my favorite memes. Y'all understand what it is?
Yeah. I'm just wondering. I'm sorry. I'm just wondering, where did they get a photo of that at the bottom picture?
Where'd they get that? No idea. Somebody was terrorizing their own cat, I think. But if you don't understand what that has to do with inverse functions, you should ask, because the understanding of the meme is kind of important there. Now that Jonathan's here, he'll explain it to you.
I can explain, yes. What did he explain?
The daily meme.
Oh, well, it's inverse. So instead of the cat eating the fish, it's the fish eating the cat.
There you go.
Instead, it's inverse. Swapping out the domains, the ranges.
There you go. Good job.